All right, welcome back. This is Coulomb's Law Lab explanations question 5 on part 2. In part 1, I cover questions 1 through 4, as well as the general theory of Coulomb's law. I'm going to be covering question 5 through the end, hopefully, with this video. Question number 5. How does the value of the electrostatic force vary with the value of the charges? So what this is asking you is, as you increase the charge or decrease the charge, what happens to the amount of force? Does it increase or does it decrease specifically? So I'm going to start by just increasing charge of 1. So right now it's at 4. And the force is at almost 200. I'm going to increase the force to 6. And now the force is almost 300. So this shows a direct relationship between force and charge. If charge increases, so does the force. This means that the opposite should also be true. If I decrease the charge, it should decrease the force. Decrease charge, decrease force. We can see that illustrated here using the simulation. So what is the relationship? Increase the charge. Use proper language here. Increasing the charge will increase the force. Okay, number 6. How does the value of the electrostatic force vary with the distance? So we're being asked the same thing. What happens to force when you change the distance? So I'm going to separate them. Right now it's about 100 newtons, and I'm going to increase the distance apart. So let's see what happens. Oh, it's getting smaller. So this illustrates an inverse relationship. If I increase the amount of distance, I decrease the amount of force. So the opposite should also be true. If I decrease the distance between, I should increase the force. And let's take a look. Yes, indeed, that's exactly what happens. In increasing the distance, well, it's clear that affirmative does not spell check. Increasing the distance will decrease the force. Now, if we wanted to get fancy and use our correct terminology, we would say that the force and charge are directly related, and the distance and force are inversely related. Next question, number 7. As shown, the two charges are 3 centimeters apart. What will happen to this force if the distance between the charges is doubled? Use proportional reasoning to find the answer, then check by moving the charges. Now, it may seem like that we're being asked here to use proportional reasoning. We've done this before, most recently with gravity, and I'm going to demonstrate how you would do that. So we're not going to plug in the actual numbers in the situation. We're not going to plug in 3 centimeters. We're not going to use 4 microcoulombs and 8 microcoulombs. We are going to use proportion to figure out what would happen. So we're basically just backing up what we came up with up here, that the value of the charge and the force are directly related, and then the distance and charge are indirectly related or inversely related. And so we want our setup to look like this, so we have to hit the reset button, reset, and we're back to original settings. Okay, number 7, show your work. It says, as shown, the charges are 2 centimeters apart. What will happen to this force if the distance between the charges is doubled? So when we're looking at proportional reasoning, what we want to do is we want to just make everything be a 1. That is the simplest way to do it. If you feel more comfortable with With algebra and you want to jump into real numbers, that's your call. But I find that this way is extremely effective, especially when I need to know, does it double? Does it triple? Does it quadruple? Does it cut in half? Does it cut in fourths? Because it tells my answer is the answer. So you don't have to do any extra things. So I'm going to just make charge 1 is going to be 1. Charge 2 is going to be 1. Distance is going to be 1. And the constant, now here's the thing with the constant. It stays constant. That's what a constant means. So this value is some long number with an exponent. But we're going to we just want to know, relatively speaking, if this gets bigger, what happens over here? We don't care about the actual number right now. So that means that this constant is going to always be the same value. So since I'm making everything a 1, I would also make k a 1. Now, since it's constant, it's never going to change. What happens when I multiply anything times 1? Well, it stays that thing, doesn't change. So I'm just going to cross it out because it's not important to my proportionality thing that I'm trying to do right now. Okay, so then let's do the actual calculation to figure out what force would be. So we have 1 times 1 on the top. That would be 1. And then if r is 1, we have to square it. 1 squared is the same as 1 times 1, so that would be 1 as well. 1 divided by 1, 1. So the force is 1. I'm going to switch colors now so that you can see clearly what my second part's going to be. And I recommend that you do that as well when you're trying to answer your lab. Changing colors makes it clear what you did. Now it says we're going to double the distance. So the distance is down here, r squared. That's r stands for radius. Sometimes they say distance, sometimes it says radius, but it's the same thing. It's just how far apart they are. And instead of 1 squared, it's going to be 2, because double of 1 is 2. 2 squared. I do my algebra. 1 times 1 is 1 over 2 squared, which is 2 times 2, so 4. So my answer is 1/4. If I put this in a calculator, I get 0.25. So either of those is fine. It's no longer 1. It's 1/4. So when I doubled the distance, the force went from 1 to 1/4. So it decreased 4 times and became a 1/4. And that's our answer for this one. Now it says, check it by moving the charges. That step involves a little bit of math, but I will show you how you would do that. Okay, so right now they're 3 centimeters apart, and the amount of force between them is 319.557. I wrote that down just to make sure I don't forget that number. And then I'm going to double the distance. So right now they're at 4 and 7 centimeters, but they are 3 centimeters apart, and that's what's important. So now I'm going to change it from 3 apart to 6 apart. So if this is 4, I'm going to move it back 3. 1, 2, 3. And look at the force. So 79.889. Now I could take 79.899 and divide it by 319 to see if that equals 0.25. Or I can do it the other way and see if this goes in 4 times. Both give you the same result. So let me show you. So the original amount was 319.557 divided by 79.889 equals 4. So this value goes into 319 4 times. That means that it is 1/4 the size of the original amount. So that confirms what we just did. Okay, number 8. So again, we're going to start by placing everything as a 1. 1, 1, 1 squared. This is also a 1, or we can ignore it. Answer is 1. Then we're going to do whatever the changes that it suggests that we do. It says, number 8, as shown, they're 3 centimeters apart. What will happen to the force if the distance is cut in half? So half of 1 is 0.5. So instead of it being 1 squared, it's going to be 0.5 squared. Okay, so if you're not comfortable with using that as a doing it without a calculator, more than welcome to use a calculator. So we know that on the top it's going to be, okay, so I'm going to use the calculator to show you that. 0.5 and then squared would be 0.5 times 0.5. So times 0.5 equals 0.25. So 1 divided by 0.25, 1 divided by 0.25 equals 4. So that's a mess. So force, instead of 1, is now 4. So it quadrupled. It's 4 times bigger. If we make the distance half the distance, it gets 4 times bigger. So then, of course, we can confirm this with the simulation. Okay, so instead of it being double the distance, we're doing half the distance. So right now, it's at 4 and 7. That was how it was originally. And then we're going to do that in half. So half of 3 would be 1.5. Note that the force is back to 319,557. And put that right at 5.5. Make sure that's lined up. Yes. Okay, and then the new force is 1,278.229. So we need to know if 319 is 1/4 of this number, or 4 times 319 is 1278. So the original amount was 319,557. And according to our prediction, the answer should be 4 times that. So times 4, ding, 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 correct answer. So 1278,228, perfect. So we just proved it using the simulation. We proved our estimation. All right, the last one asks you to change both the force, the distance and the charge. So it's a little bit trickier and does involve some algebra for sure. But I'm going to show you how you would do that. So once again, everything starts as a 1, which means that the answer over here ends up being 1. And then let's see what we need to change. So we're going to change colors so we can see it good. Okay. What will happen if the distance is doubled? Okay, so we're going to take, instead of 1 squared, we're going to have 2 squared. And what if the charge for microcoulombs is cut in half? Now, it's easy to think right here that that means we should put 2, but it's telling us to cut it in half. And remember, we're not using the exact numbers. We didn't use 3 centimeters as the distance. We used 1. So we're changing the 1 in half, not the 4. That's just giving you the exact numbers from the simulation, but we're using a proportion. So we're only using the 1s. So half of 1 is what we're doing. And it doesn't matter which one of these you pick. You're just going to change one of these to 0.5. All right, so from here we have to do a little bit of algebra. So 0.5 times 1, that's 0.5. And then 2 squared is 4. So the answer is 0.5 fourths. And that might sound insane to you. If you use a calculator, you can do that. Let me show you what you get when you use a calculator for that question. So 0.5 divided by 4 equals 0. 125. In a fraction, though, that's 1/8. Another way of thinking about this is if you have a fourth, so first of all, here's a pie, right? And it's divided into 4 pieces. If you have half of a fourth, that's an eighth, right? Because if you cut all of your fourths in half, you would have 8 pieces. So if you have half of a fourth, that's 1/8. 1/8. So fractionally 1/8 or decimal 0.125. Okay, last question. Explain how electric forces are like gravitation forces and how they differ. So to answer this question, I'm actually going to take you back to the notes from Monday, and that was discussed. So here it says it's similar to Newton's law of gravitation for masses. Differences between gravitational and electrical forces. Electrical forces may be either attractive or repulsive. Gravitational forces are only attractive. Okay, so that's all that's mentioned here. Okay, so how are they alike and how are they differ? So both electrical forces and gravitational are attractive, but only electrical forces can be repulsive. Okay, that's the end of part 2. Get your lab finished and submitted.